What if I told you that everything you've ever seen, every star, galaxy, and grain of cosmic light, might be just a sliver of what's really out there? Today, we're zooming out, way out, to explore how big the universe really is. So buckle up, hit like if you're ready for your mind to stretch, and subscribe to Cosmo Pulse, because this is where curiosity goes cosmic. You are here. Now zoom out. Keep going, still going. We begin our journey at the human scale, where here might be your room, your city. Now zoom out. Soon your entire town shrinks to a speck on a blue planet. From a spaceship's view, Earth is a 12,742 kilometers wide globe, majestic yet tiny against the void of space. Keep going. Earth fades into the distance and the moon's orbit, 384,000 kilometers away, encircles our pale blue dot. The Earth-Moon system now looks like a marble orbiting a ball, and that ball is our sun, which dwarfs Earth over 100 times in diameter. Still going. The solar system unfurls, planets tracing concentric orbits around the sun. We pass Mars, then Jupiter's orbit, then the frozen edges near Neptune, 4.5 billion kilometers out. Our entire solar system, the farthest reach of the sun's influence, is about a light year across if you include the distant Oort cloud of comets. Yet even the next star, Proxima Centauri, lies 4.25 light years beyond us. That's 40 trillion kilometers, distance so vast our fastest probes would take tens of thousands of years to reach it. But on the cosmic stage, 4 light years is nothing. Keep zooming. Neighboring stars appear as a glittering cluster. In an empty gulf 25,000 light years wide, all those stars orbit a common center, the Milky Way galaxy's core. Now you see our Milky Way in full. A spiral disk about 100,000 light years across, containing hundreds of billions of stars. If each star were a grain of sand, the Milky Way alone might fill an entire beach. And yet, we're just getting started, because our galaxy is only one of countless others. Zoom out further. The Milky Way shrinks to a luminous swirl among many. Our galaxy and its close neighbors, like Andromeda, 2.5 million light years away, form a small cluster called the Local Group. This group of dozens of galaxies spans a region approximately 10 million light years in diameter. Keep going. The Local Group is just one node in the Virgo cluster, a collection of hundreds of galaxies about 65 million light years away at its center. But even that is a mere suburb of something larger. All around galaxy clusters clump into immense superclusters and chains. Our Virgo cluster itself is part of a gigantic supercluster recently mapped and named Laniakea, meaning immense heaven. Laniakea spans about 500 million light years and contains roughly 100,000 galaxies, gravitationally woven together. At this scale, each galaxy is a faint dot, and they form filaments and walls surrounding vast black voids. We have entered the domain of the cosmic web, a foam-like structure of filaments and empty voids on the largest scales. Finally, we reach the limit of our zoom, the observable universe, the extent of everything we could ever see or interact with. From our viewpoint, this is a sphere about 93 billion light years in diameter, centered on us. Why this specific size? It's because the universe is about 13.8 billion years old, and light has had 13.8 billion years to travel. You might think that means we can see 13.8 billion light years out, but over time, space itself has expanded. Thus, the farthest galaxies whose light is just now reaching us have been carried further away by the expansion of the universe. In fact, the galaxies that emitted the oldest light we can detect, the cosmic microwave background, are now around 46 billion light years away. Multiply that radius in all directions, and you get approximately 93 billion light years across for the observable universe, a volume unimaginably vast. It's crucial to note that observable does not mean all that exists. It's simply the limit of what we can see from Earth, or indeed from any point. Light beyond this cosmic horizon hasn't had time to reach us in the age of the universe. There is no reason to think the universe stops at this horizon. In fact, no evidence suggests a physical edge at 46 billion light years. The observable universe is like a foggy bubble around us, not an edge of space, just the edge of what we can see. If you were living in a galaxy billions of light years away, you'd have your own observable bubble of similar radius centered there. For us, our observable patch contains an estimated 2 trillion galaxies and 10 to the 24th power stars, more stars than grains of sand on all Earth's beaches. Think about that. more stars in our visible universe than grains of sand on Earth, and yet, all those stars and galaxies might be only a drop in the cosmic ocean. So, how big is the entire universe beyond our observable horizon? The honest answer, nobody knows for sure. What we do have are intriguing clues. One big clue comes from the shape or geometry of space. Measurements of the cosmic microwave background and galaxy distributions show that space is extremely flat, Euclidean, on large scales, with no detectable curvature. If space were curved like the surface of a sphere, focusing far off light, we might eventually see the same galaxies repeat or detect curvature. We don't. To the limits of our measurements, the universe appears flat and uniform. If it does curve back on itself to form a closed loop, the curvature is so gentle that the universe must be at least 250 times larger in radius than the observable part. In other words, if our observable universe is a tiny patch, the whole universe would be at minimum 23 trillion light-years across, and possibly much more. And that's a lower bound. It could truly be vastly bigger. In fact, the consensus among cosmologists is that the universe is either effectively infinite or so enormous that our observable 93 billion light-year sphere is a microscopic fraction of the whole. To wrap our heads around this, imagine the observable universe as just one Hubble-sized bubble in a much larger space. Beyond our horizon, galaxies and perhaps other structures likely continue. They might go on forever, an infinite expanse of galaxies, stars and planets repeating into the distance. Or space might eventually curve or loop back in ways we cannot perceive, making the universe finite but unbounded, like how you can sail Earth indefinitely without finding an edge. Either way, how big is the universe could be a meaningless question. It's as big as everything, possibly without end. What could create a universe so vast that 93 billion light-years is just the observable portion? The leading idea is something called cosmic inflation. This theory proposes that in the first tiny fraction of a second after the Big Bang, the universe underwent a staggeringly rapid expansion, not just expanding, inflating exponentially, doubling in size over and over at a furious pace. Inflation supposedly began around 10 to the power of negative 36 or 10 to the power of negative 37 seconds after the Big Bang, when all of what is now the observable universe was crammed into a volume far smaller than an atom. Then, driven by a high-energy field permeating space, that tiny region blew up in size. Space itself expanded faster than the speed of light, which is allowed since it's space expanding, not objects moving through space. In a mere sliver of a second, the universe grew by an astonishing factor. How astonishing? Calculations suggest that even an absurdly small length, the Planck length, about 1.6 times 10 to the power of negative 35 meters, would have stretched to the size of our entire observable universe in just 10 to the power of negative 32 seconds of inflation. Let that sink in, something billions of times smaller than a proton ballooning to 90 plus billion, light years across, in a heartbeat. This was the universe's ultimate turbo boost. Inflation, if it occurred, helps explain why the universe today is so vast and so uniform. Distant regions of space that are far beyond each other on today's map were once snug together in the primordial state before inflation blew them apart. This means the part of the universe we can see, our observable bubble, could be just a tiny patch of the whole, like one pixel in a huge screen. Inflation could have stretched space so much that our cosmic horizon is nowhere near the actual edge of the inflating region, if there even is an edge. If inflation lasted even a bit longer than the minimum amount, the universe's size would be truly mind-boggling. One rough estimate based on a certain inflation model suggests the entire universe might be at least 10 to the 23rd times larger in radius than the observable universe. That's a 3 followed by 23 zeros, hundreds of sextillion times bigger. In practical terms, for us it might as well be infinite. We can't see that far ever. Inflation doesn't just make the universe big, it may also make it many. Some theories of cosmic inflation suggest that inflation might not end everywhere at the same time. It could be a process that once started, continues in some regions while stopping in others, a concept called eternal inflation. In this picture, our entire observable universe is one pocket where inflation stopped and the hot Big Bang took over, but elsewhere other pockets or bubble universes formed separately. This is the idea of the multiverse. Our universe could be one of many, like countless bubbles in a vast form, each bubble an entire universe with possibly different properties. It sounds like science fiction, but it's taken seriously by many physicists. As Alan Guth, one of inflation's founders, quipped, "It's hard to build a model of inflation that doesn't lead to a multiverse." The multiverse, if it exists, would mean that the entire universe we've been talking about, the one expanded by inflation, is itself just one bubble in an even grander cosmic reality. However, since these other universes would be completely disconnected from ours, beyond any horizon we could ever reach, the multiverse idea remains speculative. It's a fascinating thought, one we'll leave dangling as a teaser for a future exploration. Stay tuned for a dedicated episode on the multiverse. We started from you, a human on planet Earth, and zoomed out to the grandest scales we know. Along the way, we saw Earth shrink to a dot, the solar system to a mote, the Milky Way to a tiny swirl in a sea of galaxies. We realized our observable universe, about 93 billion light years across, is enormous, yet possibly just a drop in a much larger, even infinite cosmos. We learned that cosmic inflation in the universe's infancy could have expanded space far beyond our view, explaining why the universe is so vast and uniform. And we briefly glimpsed the tantalizing possibility that our universe might be one of many. So, how big is the universe, really? In truth, it's bigger than we can ever observe, perhaps truly endless. It's so big that our minds struggle to grasp it, a mind-stretching expanse of trillions of galaxies, each with billions of stars, extending far past any horizon we can see. Every time we think we've reached the limit, there's probably more beyond. It's an ever-expanding frontier that fills us with awe and reminds us of our tiny yet extraordinary place within it. And yet, here we are, small beings able to ponder all of this. As Carl Sagan noted, we are a way for the cosmos to know itself. In our quest to understand the universe's size, we also appreciate the miracle that we can comprehend such vastness at all. It's humbling, exhilarating, and deeply poetic to realize we are part of something so immense.